And with that, I'd like to introduce Cornelius Hakim, the Senior Transportation Engineer from California Department of Transportation, and Bhaskar Joshi, the Supervising Transportation Engineer from Caltrans. And go ahead, take it away.
Okay, thank you. Good afternoon for coming to this presentation. My name is Bhaskar Joshi, as my colleague Cornelius Hakim. Somebody might ask why we need yet another trash device. There's no shortage of trash devices around. And the thing is that when we have to implement these devices, we have a number of approved devices on our list. We have State Board has a whole list. So we come to implement these devices in roadway environments. We have unique challenges, as you all know. Apart from the restricted right-of-way, we have flora and fauna to watch out for. We have flooding, safety, maintenance, exposure, a bunch of issues. So one of our engineers, who is since retired, Tom Rush, he started looking at a system that could retrofit into an existing drainage system. And we tried it out in the lab. We had a limited field test. It wasn't successful. But then Cornelius Hakim here, my colleague, he took up the challenge and he came up with invented a device that now works. And it's very promising. We have now a US patent on this device, and the State Board has certified it. So I'll let Cornelius to talk about it in detail.
Thank you for a quick correction first. Thank you for coming here for this presentation. He's not my colleague, he's my boss. Again, this is going to be a tough one. 8 hours presentation in 20 minutes. So don't blink. So the name of the device is capture housing, and we name it also CH42 because the ore maintenance headquarters need the item code number. 42 is from 42 actually subtype we have, and we showed it with the CH. So the today presentation, we're going to go into the introduction. We went and then development process, hydraulic and trash sample surrogate production, the computer fluid dynamic test, about the United States patent and implementation and construction costs. Introduction. We start doing this back in 2020 January, so as old as COVID. Okay, so go back to this one. This is a view of freeways, part of freeways, and then as you can see, we have a drop inlet there. That's how everything started. How we put the device in the freeway system. So this is an aerial view of a freeway. And as a typical, you see those 4 drop inlets out there. And we got about between 200, 300 feet distances between the DIs, drain inlet. And then we have a policy in the Caltrans, at 25-year storm, you make sure that none of the water in the shoulder go into the travel way. That's our guideline. That's our restrictions. So if you do the 7 lanes, 5 lanes there, 84 feet, multiply by the distance, 300 foot. So we have about 25,000 square feet. That's about half acres. So we're thinking about, okay, the device we need to design is only up to 1 acre. So this is the initial development of the capture housing. We started with a sketch, a simple orifice and wheel calculation, put it in Excel, put the volume, trash volume what we need, the length, the depth, and play with it and see what we're going to do. And after that, we got the conceptual drawing of this. So this is the final product. This is CS Type 1. Type 1 is only have outlet, and there is no inlet. The picture you see there is the isometric diagram. There is a great inlet here where the water actually coming in, the main water. And this is the top view. The water going to come here and then go there, being filtered with all this screen. And that's, again, the section view with that. And this is the Type 2. The Type 2, we have 2 of them, which is 2S and 2D. The 2S is single pipe inlet, and the bottom one is the 2 inlets in there, because the Type 2S is the filtered water coming into the system, so you just bypass this one. The 2D is actually non-filtered, so carrying trash. And we found out during our tests that anytime you block anything, the trash just accumulates in the pipe. So that's the reason we put the safety system. because we are Caltrans is very concerned about hydraulic or flooding issues. So we have an option to do this study. We can do a field pilot project, which is probably take about 5-20 years, or we can do also computational fluid dynamic modeling, hydraulic model test, which is 1-2 years, and calibrate the CFD with the lab test. The problem with the field project is, as you see, 5-20 years. Why is that? Because there is no way you can get this stress accumulation and the runoff for a certain volume or certain flow that we can manage, because that's nature. So even 20 years might not be enough. This is a picture of computational fluid dynamic, a diagram that when they put it together, isometric view and the plan view there. This is the result from the CFD. The coloring indicate the red is the 6 feet per second, and the dark blue is all the way to zeros. And as you can see, this is where all the water coming into the inlet. And this is our concern. You got the flooding on the freeway. And this is the capture housing inside there. And then that's the outlet pipe there. This is one of the results of the CFD study, what we did. We had to do this for our designer. And we put together about almost more than 40 of this diagram for our designer. It's about capacity and the weir height, and because you have a tail of water on your drain inlet that you have to manage and design the device. The library hydraulic testing we did, we did in 2 locations, Everett and Holden. We had to have 2 locations because one without the inlet and the one with the inlet. And that's the reason we don't have time to wait. This is the diagram, and the one only with outlet only. And this is the diagram with all the piping system. This is the detail in the device itself, where we put the sealing water, the pressure tap, at the lab exactly when we did the CFD study. That's the photos of the screen weir. That's the screen box, water coming in, with the trash. Some of them stay inside, and then some of them is actually going out, being filtered and flow outside as clean water. This again, the picture from the top, water coming into the inlet. And during the test, we found out that there is an issue that when we have the water coming into hitting this wall, we get a back wave. So the water on the bottom is actually dancing. So because of that, we have to put this diversion wall in there, so the water is not dancing anymore when we did the study. This again, the whole piping system in the lab. Water going out. You probably asked me why so many pipes out there, because we have to do from 0.1 CFS into 20 CFS. And again, water coming in there into the system, going out, and then getting filtered here and going back again. This again, another picture, the same lab, but it's just a different view. That was in Everett in Washington State, and this one is Massachusetts, where we have the inlet. This one when we did the maintenance test. As far as the laboratory testing plan, we have what we call run set run set A, B, and D. The A is for the polyclock screen. Polyclock means everything is clock screen. Similar thing is full of trash. The B is a clear screen. The D is with the trash loading. And then after that, we also do the drain down test. This is we talk about that, and also maintenance test. The run set C was canceled and merged into the run set D in there. The run set A is a fully clock screen, which is the one without the inlet pipe. We have so many runs, and total about 8 tests. The run set A with the inlet, we have to do more because we have a lot more variation between the water coming into the inlet and coming from the top there. This is the photos of one of the photos of the run set A. This is the low flow, 0.6 CFS only. You see the water is only on the bottom here. This is again run set A, which is fully blocked. with high flow. The water is actually all the way cascading on the top there, 9.5 CFS. This is the result comparison between CFD and the physical. You see a dotted line, the CFD line, and the solid line is all the lab tests. And we compare, and that's how we calibrate. This is the freeboard. This is what we have to have in all drain inlet. Everything has to be 9 inches below the grade at all time. That's Caltrans requirement. Run set B is for the clear screen. We did 13 tests, and we only do it for the inlet with the outlet only. Without the inlet, we don't need to do that. We just want to know what is the highest capacity of this device. This again, the photo for run set B, the clear screen. The screen is now blocked at 0.6 CFS. This is again the side view for this screen box right there. The run set D with the threads. So it's kind of like we got all kind of duty composition test sequences, 1 to 7, runs, total flow, incremental debris loading, and all this. And total, we have about 37 tests. Each of these tests takes about 4 to 8 hours because it takes a long time to manage the water flow, and also all the debris has to be collected, dried, weighed, etc. This is the result from all the sequences, the relation between the Q total CFS and the cumulative retention. And from that graph, we put all this together. And what we come up with for our designer, we said, okay, as long as you are for the 1 year, 1 hour, which is what we call water quality set by the board, so long you are under 0.7, you can only have 35% volume of your device. You will retain almost 100% in there. This is the stress sample surrogate production photos. It took a long time to do this, about 3 months. We have to make sure all the trash is being cut, and so we can go into the grades. And we have it from cardboard all the way to vegetation model confetti. For the cigarette filter, we did have an issue with the Drug Enforcement Agency because they thought we were doing something illegal because the amount we bought is a lot. This is run set D at the 0.7 flow. 0.7 CFS. Run set D again at 0.5 CFS. You see the trash accumulate there. And this is a maintenance test picture. We use this exact truck that Caltrans use in our department. This is all the scenario with the maintenance test we did. We have about 6 runs. From 25 to 100%, and we added 2 more. At the end, we make sure we have about 1 foot of water in the end. Don't worry, I will have movie of all this. This is again picture during the maintenance test, during the cleanup. That's the 8-inch pipe from the vacuum truck. That's the maintenance test. What we want to know is how long it takes to clean this. And we take the stopwatch for each action in there, from initial equipment, etc. And then what we got is actually all of them from all the scenarios, all less than 16 minutes. Well, it doesn't take 16 minutes for hours to clean up. We have to do safety meeting, travel to the site, lane closure, etc., etc. It totals about 4 hours for Caltrans to do cleanup. This is the drain down test. This is the next topic. We have to make sure we not having any water after 96 hours. That's a requirement by mosquito infectors. And after every run set D on the trash loading test, we measure the water there. And every time, it's after 25 minutes, we only have 1 inch. And after 4 hours, almost got 2-0. In December last year, we got the patent for this within 3 months. That was quick. Again, Caltrans is a non-profit organization. We're not trying to make money for this. Yes, so the city county can always use this with our permission, of course. And then last April, we got the certification from the board. On the bottom, I have the standard plan and design. There's a lot of pages in there that I don't have the time to show it for today. Implementation and construction costs. The implementation so far we have in the South Pacific Bay, in the Sacramento County, and LA area, Orange County, and maybe in San Diego County. The construction cost of this is about $60,000 to $8,000 each, and that's a lot. But a regular drain inlet out there right now is about $20,000 to $25,000. So, all right, if you have camera, you can quick capture the video link. But I will show you the picture. I'm in the movie here. Enjoy. This is front set B with a clear screen. That was a lot of waters. Every time you see the music change, we change the testing system from run set B to run set A, something like that. So the music will tell you. So this is with the run set A with the full screen block. All the screen in there are blocked, and we put a die in there, so we try to see what's happening in the system during the thing. We met about almost 6 months on the video Zoom meeting with our consultant, our lab, and talk about this and what we can do or what we shouldn't do. We changed the system. This is when we did the test. We have about 400 videos of this. So because we took all kind of angle and see what's happening and anything what we can improve and for the system. Yeah, the timer on lab is a minute second. So because you guys don't have time, I have to speed up these videos. We have to have a lot of trash, because we have to wait and dry it first, and the dry take a long time. We cannot just speed up drying because it's gonna burn all this. We have to reuse all this trash for the next test. You just want to know when is actually the end of this. What is the maximum capacity at certain flow here? The maintenance test at the 100%, and this one is when we have one foot of water stay in there at the end, because maintenance asks how long it's gonna take with the water in there. And interesting part is actually with the water it's actually easier to clean. So the same picture here, we got 3 angles, and that's the reason this is what we cannot do in the field at all. You cannot have these 3 angles in the field for doing any tests. It is with the 1 foot of water there. We asked the person who doing this operator about make sure when you clean it, you pretend there's a lot of sediment on the bottom, a lot of leaves on the screen, and take your time because we want you to time it, and we want to know as long as possible, and that's what we did with this test, 6 of them. Yeah, the height of the truck is too high, so we have to actually break the entrance of this warehouse when we did the test. We almost canceled it, and I said, no, we have to do something. Either you break the ground floor or you flatten the, the tires, whatever. I guess I did it way too fast. Okay. Any questions? Oh, okay.
Any questions? We'd like to get you on the microphone. Oh.
Hi. You mentioned that Runset C was canceled or merged with D. What were the parameters that were originally going to be tested in Runset C, and what led to it being merged with D?
That was something to do with the debris composition we have. There were two of debris composition, and we tried to merge and put like 40% here, 60% here. And we did a quick test and said, yeah, it's no different, so we just canceled it.
Hi, great presentation.
Thank you.
Are you guys currently certified by the Water Board to be a trash capture device? And with that being said, what is the largest size of any kind of trash that you can capture?
The largest, I forget that number, but it's about 10 cubic feet. Yeah.
Is the largest piece of trash that you can capture on your device?
The largest, you cannot have it anything larger than the opening we have on the top here.
Okay.
And the first question you asked about the certification, we got it on April 13th from the board.
Got it. Yeah, sorry, I didn't see that.
Yeah, I'm sorry, I was too fast.
No, all good. Amazing. Thank you.
I told you, don't blink.
Hi, thank you. This is incredibly impressive. The
Thank you.
amount of work that you put into this. I was wondering,
That's my boss.
I think that I missed it. Well, good job to all involved. Can you clarify, I think you said this, but I might have missed it, the cost, like the capital cost per unit, maybe not all the install, but kind of just the unit itself. And then also, it sounded like the size of the unit that you're putting in is really to meet your needs, kind of how the freeway's designed. So it's designed much larger than the 1 year, 1 hour storm. So I was wondering if you could touch on that a little bit, both the size of it and then the cost.
Yeah, go ahead.
So the size is about for 1 year, 1 hour. And so what we did is at the beginning there, I didn't go over this. I went through the USGS and I looked at the 1 year, 1 hour and the 25 years. I said, what is actually in California? So I went through about 40 locations and say, what is the variation here? Because that was the purpose of that spreadsheet, the Excel spreadsheet at the beginning. I said, what are we dealing with? Are we going to have to design something for 100 CFS? And so why are we designing something for 100 CFS when we don't need 100 CFS? And that was, is that answering your question? Oh, the cost. You asked for the cost. The cost is actually install everything in there, which is like our drain inlet currently costs about $20,000-25,000. It's constructed. And don't ask about lane closure and everything and the designer cost and everything. Yeah.
Any other questions?
Okay. A lot of people say you're going to heckle me. What happened?
So how often do you clean out trash?
We asked for once a year, and that was the requirement by the board. And at least once a year. I think it's a lot of things in the design guidance, yeah. So if you have 1 acre for 10 cubic feet of trash, and that's the maximum we can like estimate. So again, trash is not like nature. We cannot predict when people are gonna unload the trash from the pickup truck.
Okay, any further questions?
This is great.
Thank you.
I know that regarding post-construction BMPs, Caltrans has a policy not to use proprietary BMPs. It has to be from their toolbox, correct? The PPDG. So are you saying then that Caltrans is okay with creating these type of BMPs for trash devices? And do you have more plans to make other devices later on or to manipulate this later on to enhance it?
Let me answer that.
Yeah, go ahead.
Yeah, so that right now, our inventor is going to retire on November 15th. So we have to find another inventor. But yeah, we don't have a policy not to use proprietary devices. It is just more difficult. It is just more difficult, because we don't get the required information mostly. Like testing like this, we hardly get information on this kind of testing from any of the vendors out here. So that's one reason why it's difficult. And of course, there are other reasons also. We can pilot proprietary devices and evaluate them. That requires a lot of considerations of funding and things like that. So, and what was your second question? Is are we going to do more of these? Yeah, I mean, if we have people come up with ideas, it's always open to people, our own internal staff to propose ideas, and we can pilot them. And we have people like Cornelius. The only credit I have is I let him do the work he wanted to do. And I don't have any other credit on this.
Is this particular device here, can it only be used in Caltrans right of way for Caltrans projects, or could non-Caltrans projects also use this as well?
Everybody can use it. I already checked with our legal, and they just asked, they just have to contact us, our legal, and put some paperwork in there. Again, Caltrans is not non-profit organization. Probably you ask a guy, what is this patent about? Why is Caltrans worried? I just told friends here that say, Caltrans has a lot of details, and I was in the payment office. We work in the LA area. Somebody saw our detail of our construction, and they copied, they patented. So we went through all kind of legal issues with this entity. So that's the reason, patent.
My understanding is that Caltrans is kind of at the forefront related to other state departments of transportation regarding trash capture. So I don't think, correct me if I'm wrong, but I don't believe other state departments of transportation have done anything similar to this, to your knowledge, correct?
No, yeah.
Okay. All right.
That's the reason we got the patent.
All right. Thank you.
Yeah, it took a good 2 years to do this, and we met almost like a continuous 6 months every week with the labs and talk back and forward, Zoom meeting. I never gone to the lab at all in Seattle or in Washington State or Massachusetts. It's all Zoom meeting, WebEx meeting, yeah. Uh-oh.
When and where will the first device be installed?
Oh, I think probably in the Bay Area. Yeah. We just going through some contract plans for that. Yeah, in the Bay Area, probably one of the devices. Unless Carl in San Diego County. No, it's not. It's not. We just reviewed the plans. It's still going on.
Are you anticipating these to be precast or cast in place, or is
Very
it open?
good question. Yeah, we got contact from precast Jensen. I'm sorry, I shouldn't say any name here. Yeah, they asked about the precast option. Yeah, we have a discussion about that. Yeah.
All right. With that, thank you, Cornelius and Bashkar.
Welcome. Thank you for coming, guys.